The third problem in our first categorical logic homework comes from section 4.3, problem set number 3, problem number 8. These problems ask us to use our Venn diagrams, that is our effective decision procedure, to evaluate the arguments, in this case direct inferences, for validity. And they want us to determine validity for both the Boolean and the Aristotelian interpretation. So let's take a look at that argument. We start off with a direct inference here. Our premise is no vampires are avid connoisseurs of garlic. Our conclusion is, therefore, it's false that some vampires are avid connoisseurs of garlic. Before we start on our Venn diagram technique, let's briefly review our step-by-step process, our effective decision procedure for determining validity for direct inferences in categorical logic. So the first thing we do is we're going to draw a premise diagram, draw a conclusion diagram. We're going to fill in the diagrams, both premise and conclusion, under the Boolean interpretation of categorical classes. So we're not going to assume that our classes have members. We want to put what has to be true in order for those standard form categorical statements to be true, regardless of whether or not those statements involve classes that have members or empty classes. Once we do that, then we're going to look at what we get when our premise is true. How does the world have to be if our premise is going to be true? Then we want to look over at our conclusion diagram, and we want to look to see what we need. How does the world have to be in order to guarantee that our conclusion is true? If what we need to guarantee our conclusion is true has to be the way the world is if our premise is true. In this case, if our premise diagram includes everything that's in the conclusion diagram, then we know that the argument is valid in Boolean logic, and we can declare that since it's valid in Boolean logic, it is valid in both Boolean and Aristotelian logic. So we'd write out valid in both logics, and we'd be done. If, however, our conclusion diagram contains something that isn't given to us when the premises are true, that isn't present in the premise diagram, then the argument is invalid in Boolean logic. And so what we have to do then is test the argument for validity in Aristotelian logic. And because we're clever and lazy, like all good logicians, we don't worry about the conclusion diagram. That's not going to change anything. We only worry about our premise diagram, and we only worry about the subject class of the premise diagram for these direct inferences. So we want to make sure that that subject class has at least one member, that there's an X somewhere in that subject class. If there's already an X in that subject class, then we don't have to change that diagram at all. And we go and test now for Aristotelian validity using those same diagrams. If there is no X in our subject class of our premise diagram, then we want to modify that subject class of the premise diagram by putting an X in the only available area, circling that X to remind us we're only entitled to that information because we're making that Aristotelian assumption that all the classes have at least one member. And then we look at the premise diagram and the conclusion diagram again, and we say, okay, here's what we need. This is the way the world has to be to guarantee that the conclusion is true. We look and see what that is on our conclusion diagram. We look over at our new modified premise diagram, and we say, okay, now that I've modified the premise diagram to reflect that Aristotelian assumption, is making the premise true, is the way the world has to be, the things that the premise diagram indicate have to be true, are those what can guarantee that the conclusion is true? In other words, if the premise is true, does that guarantee that the conclusion is true? If that is the case, what's on the conclusion diagram is also now on our premise diagram, then making the premise true guarantees the conclusion is true, and the argument is formally valid in Aristotelian logic. But we have one more step to go. Because we've made that Aristotelian assumption, now we have to go back and ask ourselves, is this argument that is formally valid in Aristotelian logic actually an instance of Aristotelian logic? That is, does that subject class have a member? Is it a good Aristotelian class? If the argument turns on that subject class having a member, and that subject class is really a class that has members, the Aristotelian assumption is satisfied, and the argument is valid in Aristotelian logic. However, if that circled X there in our subject class suggests that there's a member of a class that there is no member for, there is a property, an instance of a property that is an uninstantiated property. So if it's the class of unicorns, where there are no unicorns, then that argument, while formally valid in Aristotelian logic, violates the Aristotelian assumption. It requires that class, a class of unicorns, for example, to have at least one member when it doesn't. And therefore, instead of writing valid in Aristotelian logic, we write existential fallacy. It's committed the fallacy of making that Aristotelian assumption that there's at least one member, that there exists a member of that class, when in fact there doesn't. Let's go ahead now and look at that argument. We'll start off with our premise diagram here. We write our two circles in, overlapping. So there's an area that's just vampires, there's an area that's just connoisseurs of garlic bread, and there's an area that is both. We indicate that there's a premise, that it's the premise diagram. Our subject class is the left, our predicate class is the right. Now we say, okay, we don't know if they're any vampires. We don't know if they're any avid connoisseurs of garlic. But here's what we know. If that statement, no vampires are avid connoisseurs of garlic, is true, then there cannot be anything that is a vampire and also an avid connoisseur of garlics. And that means that intersection area, that area that is in both the vampire circle and the connoisseurs of garlic bread circle, that area has to be empty in order for that premise to be true. And therefore, we will take a moment, stop the video if you need to, think about what you have to do in that Venn diagram, and then go ahead and start the video again. All right, so if there are no vampires that are avid connoisseurs of garlic, that intersection, that area that is both B and C, that has to be empty. So we shade that area in. Now we've got what will have to be the case in the world in order for that premise to be true under our Aristotelian assumption. Now let's turn to our conclusion. Draw our conclusion diagram in, subject class left, predicate class right, indicate that it's a conclusion diagram. Now for this conclusion, we've got an it's false that clause. And that tells us that the whole conclusion here asserts that this standard form categorical statement, some vampires are avid connoisseurs of garlic bread, that is in fact false. And so one way that we can figure out how to fill out our conclusion diagram is to make a diagram and indicate what has to be true in order for that standard form categorical statement, some vampires are avid connoisseurs of garlic, to be true. So we say, okay, there's at least one thing. It's a vampire and it's an avid connoisseur of garlic. So stop the video if you need to. Think about what you'd have to do to make that standard form categorical statement true, and start the video again. Okay, we needed an X. We needed at least one thing that's both a vampire and an avid connoisseur of garlic to make that standard form categorical statement true. Our conclusion, however, says that standard form categorical statement is false. And so to make our conclusion true, we have to make sure that the conditions that would make the standard form categorical statement true never happen. So if there has to be an X in that intersection, we'll put shading in that intersection. We'll guarantee that it's empty, and that will make that standard form categorical statement false. If it's false that some vampires are avid connoisseurs of garlic, then our conclusion is true. Now we look at our conclusion diagram. This is how the world has to be to guarantee that our conclusion is true. We look over our premise diagram. Here's how the world has to be when our premise is true. We ask ourselves, does making our premise true give us everything that we need to guarantee that our conclusion is true? So we look right here. I need this area to be empty, the intersection. I look over at my premise diagram. Making the premise true guarantees that intersection has to be empty, and therefore the argument is valid in Boolean logic. Now, if it's valid in Boolean logic, it will also be valid in Aristotelian logic, and so we'll write valid in both logics.